Hey everybody, it's Mr. Forster again. Here's kind of an overview for Chapter 2. Again, this is not meant to replace the reading. You should be reading in the textbook and then working on the group study guides each week, okay? Again, I have additional lectures and stuff that are there that you can kind of watch as an overlap. One of my colleagues and that stuff have done. So you want to try to do everything inside the week. So let me go ahead and share my screen. There you go. All right, so let's scroll down here to, this is now what, week 3, chapter 2. I'm going to open up the PowerPoint. There's the study guide, by the way, but chapter 2. Bingo, here we go. All right, so what's in chapter 2? Chapter 2 is very much like chapter 1. Remember how it had those 5 different types of networks, okay? The same basic networks exist also in chapter 2, only they're calling them wireless networks because they're going to then differentiate between the types of equipment that are used in wireless versus wired connections. Okay, it starts off with the list, and I'm not sure why they left off campus area network. So there should be a WCAM, okay, and so, but if you were to do that, you would look and say the same thing. What is a personal area network at home? In our devices and stuff that we use, we're typically buying, a router from home, and we're using that router to broadcast a wireless signal around our house. If the signal isn't strong enough, sometimes we use a Wi-Fi extender, or we run a cabling and put an access point out there, depending upon how sophisticated. But that's our personal area network. Okay, we go into the next one, which is our wide area network. Okay, remember, our local area network. Now we're talking about, again, our house could be our home, whatever, but it could also be a small office someplace, or it could be a small law firm or a doctor's office or something like that. And so typically we will use wireless communications like at home, but this is now more formal because you might have multiple offices or multiple buildings in the same complex. Again, if you lived out in the country and you had a big farm and you have a lot of acreage or whatever, you might have additional buildings, barns and stables and whatever, okay, and that you might want to connect all those together. And again, we're going to be using what's called radio frequencies, and that's pretty much what wireless is. It's radio communications. We don't think about the word radio because sometimes that thing makes us feel like, oh my gosh, isn't that something the radio from the 1950s or something? And it's like, no, it's just the frequency that we're broadcasting and receiving over as a radio frequency, as opposed to a lot of us will listen to like satellite radio. So the communications are coming through satellite frequencies, which is a wireless type of frequency, but it's in the different bands of radio frequency worlds, okay? Then we go on to our metropolitan area network. Again, we know what a metropolitan area network is. Again, a lot of this is a reduplication of chapter 1, just from the wireless standpoint, okay? Who might use wireless metropolitan area? Your city governments, your county, whatever and stuff, police departments, fire, public utilities, things like that might use that as well, okay? One of my students, former students here at City College and stuff, is currently working on a project with the city of Fresno where they're putting wireless hotspots on the city buses so that if you actually ride the bus, there's a hotspot literally on the roof on certain routes or whatever, that when they do this and deploy it, if it's successful. Now, I don't know if it's going to go on every bus, throughout the city. They'll certainly pilot it for a while, but they'll see if it actually makes sense to be able to allow the people who are on a bus to be able to have a hotspot. Okay. All right. So wireless wide area network, right? Very large geographic areas and stuff. So here's where we're going to really start to use things like, what did I say before? Wide area networks. If we go beyond the metropolitan, we can use microwave dishes, satellite communications as well. Okay, same basic concept here to our structure of our network. We're doing very far different, large geographic areas. Okay, and we're going to use that communications. Okay. Again, this chapter continues to kind of be a little redundant, but we saw this in chapter 1, right, which is point-to-point communications using like from one side of Blackstone Avenue to the other side. And I think we use a microwave dish. It's a little bit of an overkill, but it was something that we had purchased back in the 70s or 80s, whatever. And so we still own it. It still works. But that could easily be replaced. It could have been a satellite antenna, whatever. I mean, it just depends between our buildings. Okay. Then we have the multi-point, right, which is what's really going on actually in our world. It really is, because we don't just connect to one building on the other side of Blackstone. We have multiple buildings and stuff. So we really have different LANs that make up our campus area network. Okay. Again, radio frequency, this is what this is all about. So this chapter is going to do a deep dive into radio frequency. I don't expect you to memorize every frequency category, but you should have some basic understanding of the regulatory agencies. In particular, when you get into the IEEE, okay, and 802.11 standard. Now, many of us have heard this standard stuff when we were purchasing a modem, okay? And again, modem is an old term called modulation, demodulation, but it's that box device that we typically hook up to our computer, and then from that we hook up a router. And if the router is going to have a wireless signal, the modem needs to talk to that router, and that router is going to broadcast at, depending upon how old the router is it broadcasting a wireless signal on the 2.4 gigahertz band or on the 5 gigahertz, or maybe you have a dual one, an 802.11n that has both 2.4 and 5. Okay, so what happens is that the 802.11 committee of IEEE established when they were doing the various frequencies. Okay, so you need to know what is 802.11, you need to know what is IEEE, and you probably should know at least some of these, whether 802.11n, gives you 2.4 versus 11b only 2.4. Okay, so it just kind of depends on how old your router is. Okay, so IEEE, again, the basic functions. There are other subletters, quality of service, advanced security, and so on. So 802.11 doesn't just stop at AC, okay? We get into the technology here. So now we get into interoperability, which is your Wi-Fi allowance. We really started seeing this with our Wi-Fi 6 category, okay? And so we needed a certification mechanism. And so the Wi-Fi Alliance organization, you might see that kind of logo out there saying, hey, we are certified, okay? Now, various interoperability certifications, we have things like WPA and WPA2 certifications and stuff that we try to use to support this communication going back and forth. A lot of this, what this does is it allows for our encryption. WPA and WPA2 are a little bit older. There's WPA3. You've got your CCMP, allows for your TKIP and stuff, RC4 encryption. What we're talking about is trying to provide some privacy over the data signal, not just simply like a radio communication. Anybody who can tune into that radio channel could listen to it. In this world and stuff, when you're running some kind of encryption or protections out there, they might hear it, but it's scrambled, it's garbled, whatever, right? And so that's what we're trying to do out there in our various ones, okay? And so there are various certifications that are established, okay? There was an older one called WPS, which is probably still on some of the older routers. Don't use it. It's an unsecured one. There was some hackers and stuff that found a vulnerability and stuff. Basically, it was like a plug and play setup, WPS certification. Okay, but you shouldn't, in this day and age and stuff, we should be using the newest encryptions if possible. But keep in mind, your router may not have that capability. Your router may only go up to WPA2, and that's it. And so at some point, we have to think about replacing our router so we can have better security and better connectivity as well. So don't use WPS. Okay, and then the rest of the chapter goes into various deployments and stuff of how you would deploy a wireless network. Okay, now this is a pretty important part of the chapter, and again, it's very long. It's going to deal with, we would use wireless in a small office. We could use wireless in enterprise and in remote locations, public hotspots, in offices, what we call carpeted space. Okay, last mile delivery issues are high intensity in municipal environments. So let's look at that again. I talked about this in the last chapter, small office, home office. Again, your personal area network can be personal, but if you're actually using it more of a business out of your home, you actually might be a SOHO by definition, okay? Because you're setting up your own server. Maybe you're broadcasting information out to other people in the community, okay? Then we get into enterprise networks. Now here's a layout of an office, okay? And we see that layout, various offices, and we have various routers or communication ports to be able to cover. Question is, since we don't have a wireless signal, we don't know, hopefully these three devices will cover everything in that overlap area, okay? So you don't have dead spots, okay? What else do we get on the, oh, here you go, public wireless hotspots, okay? So you go to a public wireless, well, where we might have a public wireless hotspot? We could have them at sports venues, we could have them at airports, we could have them at coffee shops, we can have them, like my student working on the Fresno buses and stuff, okay? Again, the word public is going to be the question, Do we have to have security? Can we just log in? You have to be very careful of hackers. So I'm always leery about using public wireless hotspots. I tend almost never use it at all. I can't even remember the last time I used one. It's a big no-no in my brain about the hotspot unless I really know who secures it. Because you could be sitting at a McDonald's and you think, well, McDonald's is providing a public hotspot, but it could be just simply another customer in the McDonald's, restaurant area. And I'm not trying to put down McDonald's, and spoofing and projecting what looks like to be a McDonald's hotspot, but it's actually a hacker trying to, get in between you and McDonald's and intercede with that, or create its own where you're just clicking on their hotspot and it makes it look like McDonald's because it says something like that. Anyway, so always got to take them with a grain of salt. Be very, very careful with that. Common deployment scenarios, what we call, again, offices or carpeted spaces or whatever. You have to deal with cost, portability, mobility, and convenience. Okay. Again, in that deployment and stuff, we would look at the standards of what we're trying to cover. Okay. And again, some of these points, if these are access points or routers, we really want them to see where the radiation is going out. Okay. So we want to see how much an area that's covered. We would almost never put one close to an exterior wall, because if it was to radiate around in the radio frequency, what good does it do outside the building unless you're trying to cover outside the building? Okay. It makes sense that I see one here. This one's maybe it's a little further, okay? But do you have some gaps in some of these areas, okay? So that's a really good question about deployments in an office scenario, perhaps, okay? In educational institutions, again, do we cover every single building? Here at the college, do we cover the fountain area? Should we cover the parking lot? Should we cover the cafeteria or the bookstore, okay? Do we cover the entire campus? It makes sense, but could cost a lot of money to cover the entire campus, and we kind of do to some degree. And the question ends up being is, but if you walk from point A to point B, you may lose a signal and your session gets broken, then you have to reacquire it when you get to point B, okay? But, again, we have good and bad wireless networks that are out there. Industry deployments, right? We have to deal with the structure of buildings and everything from how the building is made, to high ceilings and storage racks and all sorts of things that could be involved. How do we do things for a healthcare? Okay, if you go over to St. Agnes, or you go over to community hospitals, okay, a lot of times you walk down the hallway and you look on the ceiling, and there are access points in the middle of the ceiling going down the hallway. Why? Because it's more practical. We know that if you break right or left, you might go into patients' rooms. Rather than putting the actual wireless communication in every room, you can radiate it out by just simply putting these down the hallways, and then the computers that are in the sides talk to the hallway access points, okay? So it makes it a little bit easier in the infrastructure, and it still accomplishes that. Okay, so again, you look up, sometimes as you're walking down the hallways at a hospital or whatever, or a medical facility, you might see the locations, just simply going down the row or whatever, as opposed to, again, this one here, if without the radiations, I might wonder whether or not this waiting area is covered. Okay, it just depends on how big how powerful these access points or routers are. Okay, healthcare deployments and stuff, because again, we expect those things to be running 24/7, 365, right? We don't want to go into a doctor's room and say, hey, the computer doesn't work. What if he needs access to your medical records? The old days of getting your medical file and bringing it with you. Yeah, that doesn't happen as often, except in small medical facilities. I go get my dentist office. They still have a physical file folder. They have a digital stuff too, but the file folder is the easiest, fastest, convenient way for them to do charting and so on. Okay. What else? Healthcare deployments, patient information, whatever. I'm a big fan. I've been using Kaiser for a long time. And so Kaiser has been really up to date with accessing my medical information, having communications with my doctors, getting test results. And now in this day and age and stuff, I kind of tend to expect to have that from everybody's medical providers and not just somebody like Kaiser or whatever, okay? Again, high density deployments, okay? Should we have these downtown at City Hall or in the public parks, right? Roding Park or Woodward Park, should we have hotspots out there, okay? And then again, we also look for municipal law enforcement overlaps and stuff because, police officers, need to be able to talk when they're in their car, and then they have to have radio communications that also go off of their vest. And then, of course, anything that deals with support services besides that, including the fire department, let's say. So hopefully this is a good overview. Again, if I have some videos, I'll put them into the weekly folder. But I think that's it for now. We'll see you on the next time. Let me go ahead and stop my sharing here and stop the recording, and you have a great day.